Hello everyone and welcome to 17th Lucknow Mulesoft Meetup. The topic for our today's discussion is fault tolerance in API invocation. Organizers for this meetups are Akyu, Brutus and myself. So we are the organizer for Lucknow Meetup and I'm skipping this part. Okay, and let's head up to our speaker. So speaker for our today's meetup is Ankita. So Ankita, would you like to introduce yourself, please?
Sure, Abhishek, thank you. So, hello everyone, good morning. My name is Ankita Mishra Shahi, and I am working in IT industry for last 12 years now. I have to update that. And in my previous work experience, I have been working as a quality analyst. In testing domain, I have been into customer support as IT analyst, and currently I'm working in Epicero as a manager technical training. And here I'm a trainer as well as I manage all the technical training in the organization. And currently I'm MCD and MCPA certified. Thank you.
Thank you, Ankita, and thank you so much from the Lucknow team to take this up and bring up this amazing topic. Okay, thank you so much for taking it up. So let me read out the safe harbor statement. So both the speaker and host are organizing this meetup in individual capacity only. We are not representing our companies here. This presentation is strictly for learning purpose only. So organizer or presenter do not hold any responsibility that same solution will work for your business requirement. This presentation is not meant for any promotional activities. Some housekeeping. So the recording of this meetup will be uploaded in the event page within 24 hours, and I will share the link of the page in the chat also. So within 24 hours, you can visit and you can get the recording over there. If you have any questions, so most of you have got the mic access. So y- please feel free to unmute and ask your question, or even in the chat you can put it up and we'll try to answer you uh, all your queries and questions. And the most important is the feedback. Please give your feedback. You will get a form once the event is done. You will get a mail with the form, so please fill up the feedback. That is very important for the organizer as well as speaker to improve. If there is anything required from your end, any topic which you want us to cover in our meetup, you can put it over there. You can suggest any changes you want in our meetup. You can do that. You can suggest that. So please put up the feedback over there, and that is very much important. So all over to you, Ankita. I will give you access now. You can take it up and you can carry on from here.
Sure, Abhishek, thank you. Let me quickly share my screen. I believe my screen is visible.
Yes, Ankita, it is visible.
Yes, yes.
Okay, perfect. All right. So once again, welcome to all of you. Today we are going to discuss about the importance of fault tolerance in application network. So I would really encourage everyone to participate in the training and make this session as interactive as we can, because I know we all are here from different backgrounds, different domains, and most of you might have encountered a lot of practical issues and practical implementations as well. So we would love to hear it from you because it is a knowledge sharing session. So please make sure to make it interactive. Okay. So today in this session, we are going to talk about API-led connectivity approach and application network. Just an introduction. I'm assuming that all of you know what is this API-led connectivity approach and application network concept. After that, we will talk about the effects of failures on application network. Then we will talk about what is an API invocation, and after that, we will discuss about fault tolerance and its strategies, followed by the wrap up and the conclusion. Okay. So API-led connectivity approach, it's a way to connect data to applications through reusable and purposeful APIs. That's the whole and soul, mantra of Mulesoft. It's an integration platform, as we all know, and the way of connecting the data, application, and everything is through the concept of reusability. And that is the reason why API led connectivity approach is such a big hit. It's such a it's such an important mechanism nowadays today, because to overcome the IT delivery gap that we are facing in the IT industry because of the constant changes which are which we are facing in our day to day lives in the IT industry. So in API led connectivity approach, I believe you all are already aware of it, but let me quickly take you through. We have divided our APIs into three layers. system APIs, process APIs, and experience APIs. So, how it works? The client will make a call to the experience API, and in experience APIs make calls to your process APIs where the logics are written, where the orchestration happens, and the process API pull out the data from the system API, which is whole and sole the whole and sole responsibility of system APIs is just to interact with the base system. They are there just to interact with the data, addition of data, deletion of data, all the CRUD operations, security, scaling, everything can be done by the system APIs. But each and every APIs that you are seeing right now, they themselves are independent products. Okay, so each API, they undergo the complete API development life cycle, and that is the concept of AI API led connectivity approach, reusability and consumption. Rather than doing the repetitive task again and again, I would like to create an asset that can be reused no matter what kind of changes are going to come up in the market or what kind of demands my clients are going to put up in front of me. Okay, so I just do not want to do the repetitive task. That's why these assets are reusable in nature, they are consumable, and they are self innovative. Okay, now, since we are talking about the concept of reusability, for example, this API that you can see right now, S1, that had been created for this particular project can also be used by any other project in your organization. This is how an application network is created. It is a way to connect the applications, data, and devices through APIs that exposes some or all of their assets and data on a network. So now, when you are actually developing an API, you are not only contributing to a single project, but you are contributing to the entire application network, because you never know which other project might use your API in future. Okay, so again, this is again emphasizing on the concept of reusability and consumption. Definitely, application network represents the cultural shift. It emphasizes on not how many assets are present on the application network, but rather how many consumers are getting value from it. So that n number of APIs which are actually present in the market, are we able to consume them in any other projects or not? Are we able to reuse them or not? That is how this application network is developed. And it's a very beautiful line written over here that application networks are recomposable. It bends, but it will not break. So whatever changes that you are going to do, it is built for that change. Okay. Now this all sounds very nice, right? All my donkey work has been reduced. I'm able to, deliver my products fastly because I'm not doing all the repetitive tasks. I'm more focused towards innovative tasks. Everything, it looks very cool. But what happens when there is a failure? See, now when the number of APIs are actually involved or reused in an organization, the degree of dependencies between the APIs are very high, right? Because now uh, on one API, it is not only one project which is dependent upon, right? There are multiple projects which might be consuming that same API. Or in the same project, if I'll say, there are multiple levels now. It's not a monolithic architecture anymore. So there are multiple layers of APIs that we are dealing with. So sorry about that. High degree of dependencies between the APIs are also there. So when everything is good, nothing will happen. Everything is good. We are very happy with this particular approach, and everything is very smooth. But if there are any failures of an API, it may affect any other APIs which are interconnected with each other, isn't it? And if unchecked, the failures in the API invocations propagate transitively through an application network. Now, if one API is failing, definitely it will have an impact on other APIs also which are consuming it. And overall, it is going to affect your entire application network. So unlike other approaches like your project based approach, where you are creating one particular node, and that node is only dependent upon that particular project, or that project is dependent on that particular node. If that node fails or it is not working, it's just that particular project that is getting affected. But here your entire application network might get affected. The thing is that errors can cascade and cause the downstream failures, and that is when fault tolerance mechanism come into the picture. That I do not want my errors to get cascaded, rather I would want to mitigate them. I would like to handle them, and I would like to present it to my client in a graceful manner, so that all the consecutive APIs, or all the cascaded, all the connected APIs should not be affected because of one single failure. That is the idea behind this fault tolerance. So the fault tolerant API invocations are very critical for successful application network. Okay, till now, any confusions? Are we good with the concept of application network and the effects of failures?
Anyone, any question, guys? Because I don't see any question over the chat.
Okay,
So
perfect.
suppose, yeah, you are
Uh-huh.
saying that in application network, if any of the API, because it's being consumed by many project or applications, so
Mhm.
how it means we are going to handle it?
Yeah, that's what we
Mm,
are going to discuss now, Anjani. Yeah,
okay.
we are going to
Mm,
talk about all the fault tolerant mechanisms now.
mhm,
Okay, but right now, let's first understand that what is the effect? What will happen
mm,
if we don't handle it? Right? Unless and
okay.
until we will not able to understand the criticality,
Yeah.
we will not be able to focus on the resolutions. Right?
Yeah.
So I think now till here we are good.
Mm,
Correct?
yeah. Yeah.
Perfect. So let's talk about API invocation and fault tolerance. So what is an API invocation? API invocation is nothing but when an API client makes a call to your web API implementation via its own API. Okay, the way it is making a call, it is called as API invocation. Now just try to understand one thing. API client can be an external client also, right? As well as it can be the connected APIs as well, the API implementation of your previous API also. Because in API led connectivity approach, you know that experience API calls your process API. So when I say experience API calls the process API, what does it mean? It means that your implementation, API implementation of experience API is making a call to the interface of your process API. Similarly, the process API implementation is actually making a call to the interface of your system API. So a web API client could be a web API implementation as well, which means that if something fails, it should not get cascaded, or it should not affect the APIs in the downstream. And that is why we have to handle it using your fault tolerance mechanism. So what will happen if my API is failing? If my downstream API is failing, I do not want my interface or client to get get the same error messages, or the error should not start cascading, because one, if anything happens to this API, it will affect this API also, and at the end of the day, it will affect my API client also. So if any error is happening over here, I need to handle it right over here so that it should not get cascaded. We need to mitigate it right over here. That's the idea of your fault tolerance. Okay, so fault tolerance is a requirement, it's not a feature. Okay, but it is a very very essential and critical part of an application network, and I think now you all know the reasons. It is actually used to break the transitive failure propagation, the same thing we are talking about now, that the cascading of error, the error propagation has to be controlled, because we know that failure will happen. You cannot control that, no matter how much beautiful application you are going to make, error free application you are going to make. Since you are living in the world of distributed systems, and especially in integrated platform, you are actually connected with multiple other systems also. So you never know, there are various chances of failures, right? Maybe a system is not responding, maybe the network is not fine right now, maybe authorization error is there, maybe too many requests are there, maybe service is not available, any kind of error can happen, but you have to be ready for that. Because until and unless that error is not handled gracefully, it might affect the entire channel, other APIs in the row, and finally your your client is going to get frustrated at the end of the day. Okay, so what are the strategies? So Anjani, now your question is going to be answered. How can we handle these errors? So
Okay.
there are various strategies, okay, that we can use in Mulesoft. First strategy is fail fast, don't freeze. Okay, we will talk about all these strategies in detail. So first strategy is, just if you are not responding, fail. Okay, I don't want to wait for you, because sometimes just imagine you are browsing something on the internet, and the response is not coming. You can see that circle is continuously moving and moving and moving. Don't you think you get frustrated? What you will do, are you going to wait, or you are just going to close that window and you're going to open or browse to any other channel, right? Same thing, clients do not have patience. If it has to fail, just fail. I'll handle it further. But don't keep me waiting. That's the idea of fail fast and don't freeze. Then we have a beautiful concept of circuit breaker. Okay, what about circuit breaker? Again, we will discuss about it in detail. Then you can also invoke a fallback API. After that, there is a client side cache. Cache mechanism can also be used. And at the end of the day, when nothing works, go ahead with static result. Okay, let's talk about all these features, all these strategies one by one. Any questions till now? Everybody is good?
I guess so. Nothing in chat.
Perfect. Okay, so the first strategy, fail fast, don't freeze. As I gave you an example, right? That you can't ask your client to wait because multiple APIs down the stream, they are connected with each other and they all might get affected because of that particular time period delay. So we will go ahead with this particular strategy. The first strategy under fail fast is timeout. You can set your timeouts for your web API invocations carefully. All right, so you can actually based on different protocols, you can decide that until and unless I don't get this particular response within, let's say, 1000 milliseconds, just give me an error, I'll take it up. Okay, but I'm not going to wait more than 1000 milliseconds. That is the idea behind your timeout. Okay, but how are you going to handle the timeout? Because there are different APIs, and as I told you in the beginning, that each API is itself a single product. They all will undergo a complete API development life cycle. So you all are gonna create your policies, your timeout mechanisms in each and every APIs that you are going to create. And here in application network, you never know, multiple APIs are interconnected with each other. So you all might have heard about that SLA policies, right? Service layer agreement. What happened there? In service level agreement, you actually have to create the rate limiting. You have to create the timing that I am going to take this response only up till this particular time period. There are different service levels that you can create. So based on that SLA tiers of your API client, you have to set your timeout, and it has to be as low as possible. It should not happen that your SLA is still getting invoked and your application gets timed out, or vice versa. So you have to be very very uh, you know um, very technical when you are actually going to create a timeout, because you have to understand the SLA of all the downstream APIs which are interconnected with each other, and based on that you have to select or you have to create the timeout. Okay, so timed out web API invocations are indistinguishable, because you never know that why the timeout had happened. Is it because of the actual error? Something had really happened, or is there something related to network connectivity, or let's say the application is not responding right now because of some other reasons? We never know. So with timeout, one thing is for sure, that you will not able to make out that what had happened to your backend system, or what had happened to your the system that you are invoking to. That is the reason, along with timeout, it is always suggested to add additional fault tolerance strategies. Generally, timeout can be used in Mule applications at the level of HTTP request, where the default is 1000 millisecond. For an entire transaction, also we can use a timeout, as well as you can also use timeout for scatter gather, which are a part of your higher level control constructs. Okay, all good with timeout? It's a very basic, very simple thing, right? You all might have already used it. Any questions? Okay, now as I told you that with timeout it is very difficult to understand that whether the error is really something had happened with my downstream APIs, or it's just that connectivity issue or something related to service not available or not responding kind of error is happening. So in that case, you can use retry mechanism. Again, this comes under your fail fast, don't freeze strategy. Now here what we can do, once failed, API invocation might succeed in case of retry, right? Because in timeout we are not clear. So in that case, what we can do, we can use this retry mechanism. But again, be careful. When you are using this retry mechanism, try to use it only for the transient errors. Now imagine you are making a call to the application and you are getting the error like 401, unauthorization. Now, unauthorization error is a permanent error. It's not a transient error. Now, no matter how many times the client is going to invoke that API using the same credentials, it's going to fail. Am I right? No matter how many retries you are going to add. So retry will never work with the permanent errors. It will only work with your transient errors. Now, what are the transient errors? Errors like request timeout, too many requests, or most of the 5xx error codes, they all come under your transient error. But again, generally it is very difficult to understand, right? Because you never know that when the API invocation will happen, what kind of error is going to happen. So generally in real life, we put this retry mechanism on all the errors, but it is not suggested. It is generally suggested to put it in the transient errors. Second, it should be applied only on the idempotent methods. Now, what is the idempotent method? Any idea, guys? Anyone would like to answer?
which should not change the behavior.
It should
Absolutely.
not be a duplicate one. That's the method what you have mentioned over here. That is
Mhm.
there.
Absolutely. So basically, idempotent methods are the methods which do not change the response. Okay, for example, get method. What is a get method? It's a read operation. So no matter how many time you are going to read a data, it's not going to change the response. It will be same. Delete method. Now, once it is deleted, now no matter how many times you're going to retry the delete operation, once the data is deleted, it's deleted. It's not going to change the data again. Okay. So all the methods which do not change the response are called as idempotent methods on multiple retries. So it's always safe to do the retry mechanism on idempotent methods. Now the methods like post method or your patch method. Now what will happen there? Post is something where you are adding something to the base system. Now what will happen if you will retry again and again? The same data will be added to your base system or your connected APIs again and again. So apart from these methods, other methods are not considered as your idempotent methods. Okay, and retry mechanism should only be applied on your idempotent methods. Now, how to add the retry mechanism also? Here also you have to be careful, just like timeout. When you are adding a timeout, you have to be very careful about the SLAs. Similarly, in case of retry mechanism also, you have to understand the protocol. Try only few retries. Okay, don't go ahead for n number of retries. If you are like having 10 to 15 retries, your client is definitely going to get irritated. It's just like freeze condition, right? So in that case, just keep 2 to 3, not more than that. Try to reconnect with your system, retry, add this retry mechanism for 2 to 3 times, and we are good. Short wait times between retries. Of course, between the retries, the time period should be very less. Short timeouts for each API invocations also. Correct? So why are we doing this? Because of the strategy. Fail fast. Don't freeze. If you can't give me the error, fine, I'm okay. Clients, otherwise, your other API clients or the APIs downstream, they might get affected. They have their own SLAs, they have their own mechanism. And in application network, you have to be careful that one API is not only consumed by your one single API, rather it is consumed by other different APIs also in the network. So it might actually affect the functionality of other APIs also. So it's always better to fail fast. If you are not able to respond, good, no problem. But give an intimation to your client that, hey, you can take it up. Okay. So in Mule application, you can add your retry mechanism in HTTP request connector until successful scopes. And there are many other examples. These are just a few examples written over here. Okay. Any questions with the retry?
Ankita, one question.
Yes.
Hi. So the put method, right? It is almost similar to post. Like if it is not available, it will create one.
Yes.
So if we retry too many times, it will again be a problem, right? So how
Yes,
does
this is
this?
this is a very popular question. Why put is an idempotent method and post or patch are not an idempotent method? Okay, before I answer, anyone wants to share their thoughts? Any idea, guys?
As far as I know, put is for updating completely whatever is
Hmm.
there, but it won't create. That is my understanding.
No,
I could be wrong here.
yeah, put is something first time when you do that, when you say that unique, it will going to create an object. I suppose that same request is coming, it will going to just update it. Okay, so
Hmm.
that's the reason.
Absolutely, absolutely, Anjani. And sorry, who was there? I missed.
Anjani Kumar.
Yeah, Anjani, and I think
Yeah.
somebody else also answered, right? Uh, okay. So yes, basically what happens, uh, see, put method is where you update a system. Okay. So if that particular content is there, update it. If not there, you create it. But once it is created, it is done. It is not gonna update, recreate, the row again and again, or that particular entry again and again. That is the reason put comes under your idempotent method. However, Mahalakshmi, it's very, very important for the developers to follow the protocols. Okay, you cannot write a code where you are going to do repetitive addition or repetitive updation under your put method, because that's how put method is defined. Once updated, it's done. It's not gonna change again and again. Just like delete operation. Once deleted, it's deleted. It's not gonna delete once the resource is deleted. Do you think it will be able to delete again and again? No matter how many invocations you're gonna make. Similarly, put method also. Once it is updated, it's done. Now, no matter how many times you're gonna update, it's not gonna recreate that particular data for you. Got it?
Yeah, thank you.
Yeah, makes sense. So, but yes, thank you for pointing it out. The developers have to be very, very, mindful when they are creating these methods. They should not break the protocol. Okay, under get method, they should not write a code where people can make any changes, like adding a data or deleting a data, something like that. Similarly, for put method, it's very important to follow the ideal definition of a particular method. All right. Okay. So we can see that timeout and retry, they both come under fail fast and don't freeze. And generally we use timeout and retry together, because as I told you that just using a timeout, you won't be able to figure out whether the application has really failed or not. Because if the downstream application is failing or the system is failing, you need to work on that also. If it, or you need to intimate the corresponding, owner or the stakeholders. All right. Now, next is circuit breaker. Again, a very interesting fault tolerance mechanism. So generally, circuit breaker is used in a distributed environments where what happens, multiple remote resources and services are integrated with each other. So when multiple resources and services are talking to each other, they are interconnected with each other, the chances of failures are more, right? And you have to handle them because you are an application network, and now we already know the effects. Now the failures can happen due to timeout, slow network connection, or the resources being temporarily available, like transient errors. Okay, if the error is permanent, can't help it. Definitely the owner or the stakeholder will have to take care of it, or if you are the owner, you have to take care of that. But if the errors are transient, we need to handle it. And for handling these kind of errors, circuit breaker is one of the very interesting feature. Now, circuit breaker allows the system to stop making requests and allows the external service to recover under a reduced load. Now, in case of circuit breaker, what happens? Instead of invoking the corresponding API continuously, you give that particular resource or system some time to breathe, some time to recover. Okay, how that will happen, we'll talk about it in a while. But it actually gives some time to breathe, so that if the errors are really transient errors, we should be able to handle them. Okay, now what happens generally when we are talking about business, for example, let's say you as you as a customer, you want to order food through Zomato. Okay, now Zomato is taking your order, but for some reason, the backend system is not able to process your data. What will happen? Your data will go to the queue, right? Zomato must be having some queuing mechanism where it must be taking all the incoming requests and queuing them up. Now, let's say your request is not getting processed. What will happen now? You, as a customer, you might get frustrated, right? And you might want to log out. Once you will log out, it will cost a lot of money, or it will a, cost too much to a business. So definitely business don't want to go in loss, or they do not want to lose you as a customer. So what they can do, they can handle the circuit breaker. They will put your request in the queue, okay, and give the backend system some time to breathe. After certain time, once the system is recovered, your request will be taken up. So instead of giving you a request that, hey, we cannot process your order, and you making frustrated, What they can do, they can keep you in the waiting list, give the backend system some time to breathe and recover, and then after that they can process your request. And if even that is not working, even then your request is in the queue, then it will be sent to a dead letter queue. Dead letter queue is something, for example, for a very layman term, I can say that, let's say a human intervention will be there. Okay, so it will be handled manually then. So what will happen in in this particular entire business, the customer is also happy. Definitely he has to wait, but at least the business is fine, right? Even the customer is happy that his request has been processed, and the business is also happy that they didn't lose you. So generally circuit breaker is used in case of the queuing mechanisms, where a lot of requests are coming in, your backend systems are processing the data, but if something happens, you, instead of overloading your data, you will give the system some time to breathe. Meanwhile, your requests will be there in the queue. Once the system recovers, then automatically your requests will be processed. If not, then instead of giving you a wrong message or a negative acknowledgement, they will take it up in a dead letter queue. So possibly they will use a human intervention or any other procedure, which depends from organization to organization. Okay, so the idea of circuit breaker is clear. Okay, so in the circuit breaker, there are different states: open state, half open, and closed. So let's talk about it in the upcoming slide. So basically, let me give you one more thing. Let me elaborate one more thing. Circuit breaker is a mechanism. Okay, this is an idea that we spoke about. Now, this feature is by default available in any point MQ in our Mule 4. However, the same feature can also be applied on any other queuing mechanism, but they are not available by default. You may have to write your own groovy scripts and your own code to implement this particular feature in any other queuing mechanism. But by default, you can utilize it in your anypoint MQ. So let's see how does it work. Circuit breaker, as the name says, right? Definitely it has been derived from an electrical term. So what happens? You have a power source, and this is your bulb, as you can see that. Now, the moment this connection will break, this bulb will not get lighted up, right? The power is not going to be supplied. Once the state is closed, you can see you are all enlightened with this particular bulb, right? Same thing will happen in the circuit breaker. The same concept of open state and closed state can be applied over here. Same example I'm going to talk about. So let's say you are a client, and you are sending some requests uh, to your server. Now what will happen? There is a queuing mechanism, as I told you, and your requests are going to be accumulated in this particular queue. Now in my flow, I will have a subscriber that will pull out each messages or each request from the queue, and it is going to process it further. In the processing, let's say you are going to publish it further to a particular queue. Just imagine that the third party system or the third party server is down. For some reason, the publishing to another queue is not happening. Okay, the transmitting of the data, the transmitting of the request to your backend system to or any third party system is not happening. So what I'm going to do, I will open the circuit. Instead of loading my third party or my backend system with loads of messages or loads of requests, I'm going to give them a breather. So basically, circuit breaker has three properties that you have to use. One is error type, that which kind of error types you want to set as a condition that this kind of error will happen, then only you have to open the circuit. Otherwise, we are good. You can continue. Second is your error threshold, that how many times the error has occurred. For example, if one time the error is occurring, you are not going to open the circuit, right? Maybe let's say you have kept the error threshold as 5. So if consecutively 5 times the error has happened, it means that something is wrong with my system. So what I'm going to do, I'm going to open the circuit. And the third property is strip timeout. For how long you want to keep your system to be to recover. How much time you want to give your system to recover, so that after your system will get recovered, automatically the circuit will get closed and the communication will start again. So that's where the states come into the picture. So open state is when the connection will stop. Closed state is when the connection is smooth. Now what is this half open state? Now let's say You have set the error type as uh, client authenticate no let's say timeout error, something like that. Okay, timeout is happening from your backend system. So when that happen, that error will happen 5 times consecutively. Automatically, your circuit will open. The moment the circuit will open, just be mindful of this, that the corresponding requests which are already getting processed, they will continue to process. Okay, nothing will happen to the requests which are already published or which are already in the component phase or acknowledgement phase. They will continue to process. However, after, let's say, you have given 2 minutes trip timeout, after 2 minutes your circuit will be closed. Now once the circuit will be closed, I mean once you can see the circuit is closed again, all the requests are not going to be consumed again. Only one request will be consumed, just to have a dry run, just to have a check whether the system has already recovered or not. Okay, so for example, let's say first request has been processed, but again the system is not system is failing, or it is not giving me the successful response. What will happen? It will not wait for the threshold to complete, it will not wait for 5 requests to fail again. Rather, it will open the circuit again. That condition is called as half open. Okay, so half open state is mostly for the dry run. It is only going to check for one request to see whether the system has recovered or not. If the first request is recovered, then it will go to a complete closed state, and after that multiple requests will start processing which are there in your queue. But in case of half open, only one request will be processed. If it fails, then again the circuit will open. If it pass, then it will be closed. Understood the concepts, guys? Any questions?
Yeah, Ankita, this is Jay here.
Yeah, Jay.
Um, so the thing, right, we are doing for half open. Do we need to code this thing, or this is kind of mechanism that Anypoint MQ is already having?
Yeah, it is already having in any point MQ. That's why I told you that this particular feature is already there. In global configuration, you have a circuit breaker feature, and you
Mhm.
can set all the timeouts, strip timeout, and every property you can set it over here. But all
So
other queuing mechanism, you have to write the script on your own.
the half open also is present. Like let's say the first, if the FIFO is maintained, then the
Hmm.
first message will pass through, and if success, the circuit will be closed, and the other messages will go through. If not, it will open, right?
Absolutely, Jay.
Okay.
Yeah.
Okay.
Okay.
Yeah. Thanks.
Yeah.
Yeah, just to add, like I've also
Yes,
shared a
Abhishek.
link in the chat where I've explained like how this circuit breaker works, so you can also see that. And coming to you, Jay, like as Ankita already mentioned, it is a part of your Anypoint MQ circuit breaker configuration. So there you will see there are several configuration to configure like how many times you want to retry. Okay, for the first time when you get an error, so suppose you are calling a HTTP connector and you are getting some connectivity error, and you have put the threshold as 2 for the first time. So for the two for the for 2 time it will first try to connect to that particular HTTP requester, then it will go to a closed state. Then there will be a threshold for like for how much time you want to hold it. Now say 30 seconds. So when it is in closed state, it will wait for 30 seconds, and then it will try only once. Okay, it won't try 2 times, it will try only once to check whether the error is gone or not. That is called your half open state. Okay, and you can see the video, like I have shared it in the chat.
Yeah. Okay. Yeah, that makes sense. Thanks, Abhishek. Yeah.
Thank you.
Yeah. Thanks, Abhishek. Okay, perfect. So everybody clear with circuit breaker? Okay, sorry. All right. So this is one of the mechanism that we can again use as a part of fault tolerance. Now in this particular feature, what are we going to do? We are actually giving some time to our backend system to recover, and this particular feature is usually applied on your queuing mechanisms. Okay. Now let's talk about fallback API invocations. Now in case of fallback API invocation, what we can do, we can have when you are working on an API, you do not work on a single API. There are multiple other APIs also which you can keep as a DR, or you can keep it in your other cloud hub region. You can keep multiple API services like that. So when your API, you have done all the mechanism and still your API is not working and you really need some time to recover your API, in that case, what you can do, you can route the requests to any other fallback APIs. Okay, and these APIs could be your disaster recovery APIs, could be your any older version that you might have kept and you have not deprecated it yet, or it could be any newer version also where you are working on certain functionality and still it is not yet exposed to the client, but it has that particular feature for which your client is demanding. So instead of letting your downstream suffer or let them face the issues because of your errors, you can route the request to the corresponding API. Now try to understand that this is not an ideal way. Naturally, this is not an ideal way, but it is sufficient otherwise. But it is sufficient. And this particular APIs are, as I told you, that it could be, an older version or a disaster recovery API, or it could be any, advanced APIs. It's not similar to the primary API. Otherwise, you could have two primary APIs also. Fallback API invocations are generally used, as I told you, that when one API is failing, then the request will go to your fallback API. The same mechanism can be applied in parallel, where both your primary API and fallback API both are active at the same time, and they both are happy to take your requests in parallel. In this particular situation, what will happen? The first response to arrive is used. So whichever API will respond first, that response will be taken by the client. Definitely, it reduces the overall execution time. But as you can see, you have to make two APIs, up and running all the time. The maintenance will be needed. You have to make sure that both the APIs are working fine. So it definitely increases the load on the entire application network. And this approach is a very egotistical approach. Okay, and it is generally used only in case of extremely critical business or applications, because as I already told you, it affects your cost, it affects the load, it affects the entire application network itself. So it is generally used only in the exceptional cases. Okay, so this is the idea of your fallback API invocations, where you can have uh, you know uh, 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 an API as a, what can you say, as a I'm not able to remember that word. What do we say, it's like when you are, your actual API is not working, then there is one as a standby, sorry, as a standby it is there. So you can route your request to the standby APIs. Okay, we already know the approaches now. It can happen one by one or it can happen in parallel, but parallel approaches are generally not appreciated. It is only appreciated in case of exceptional cases. Okay.
I got
Okay.
one
Huh.
question. So, will this fallback API be a similar copy of the primary one, or how
No,
it will be?
no. That's why we said, right, that if it is a similar copy, then you would have two primary APIs working at the same time. But why would you want that, right? So generally, a fallback API could be a disaster recovery API, one API that you have actually, created for the disaster recovery, or it could be an older deprecated version. So let's say there is one API which is already marked for deprecated and you have routed your clients to any other API endpoints, but your current API is not working. Then instead of throwing an error to them, you can route it to an older version. Okay, so it's not necessary that your older version, your fallback API and the current APIs are exactly similar to each other. Okay, they cannot be mirror image. Sometimes what happens, they can be mirror image also. I'm not saying that it must not be, it can be. Sometimes there are APIs which are hosted in different regions. So what I can do, I can route it to route it to the API which is deployed in any other region also. Even that is possible. Next option of fallback is that, let's say there is one API on which you are still working on, you want to add more properties into it, you want to make it more advanced with lots of features and everything. Currently it is not exposed to the client, but it is deployed and it is in the test environment and so and so, but it has the features which the client is looking for. Then instead of giving an error to your client, you can route the request to that particular fallback API.
Okay,
Okay, where you are not exposing all the advanced features, but yes, at least your client should be happy for a while.
it is like the API with reduced or improved functionality.
Sorry,
No,
by
it
mistake
is
I said,
it is like the API, API only, but with maybe deprecated or
huh.
improved functionalities.
Absolutely, absolutely.
Okay.
Okay, all right. Okay, so next we have client-side caching. So caching mechanism is also one of the way to increase the performance, as we all know that. So in case of fault tolerance, even you can use the caching mechanism, right? So in case of client-side caching, what will happen? Definitely you will use the client-side caching because your server is already not responding. So if you will use the server-side caching, no use. Because server, if it is going to respond, then why do you need even a cache memory? In case of fault tolerance, cache memory has its own significance to increase the performance, to decrease the load on the implementation. But when it comes to fault tolerance, definitely we would like to go ahead with the client side caching. Now, client side caching by the web API clients are the great source of fallback results, right? It also increases the performance. Now, in this situation, the API client needs to implement the client-side caching where the results of the API invocations are preserved indexed by the input. What is caching? We all know, right? That once you invoke your API implementation, whatever results that you are getting, you can store it somewhere so that next time you do not again have to make a call to your implementation so that your API implementation will not get a lot of loads. Rather, whatever is the stored memory, whatever is the preserved memory, depending upon the indexing, of course, you can respond back to your client. Again, only responses from the safe HTTP method should be cached. Now, we talked about idempotent methods, right? Now, here we are talking about safe methods. Safe methods are the methods which do not make any change at all to your system, to your data, like get method, head operation, options. So basically the methods which are only used for read mechanism. Definitely when you are performing a read mechanism, you are just retrieving a data. You are not performing any activity on that. You are not making any creation, updation, deletion on that particular data. So these methods are called as safe methods. And it is ideal to store the it is ideal to have the caching mechanism only on the safe methods, which is quite obvious. If the user wants to delete something, how can you delete the data using a cache memory? The user, you actually have to invoke your implementation to delete that particular instance, correct? But the user, if the user wants to read a data, then it's okay. You do not need to make an invocation to your implementation again and again. You already have the preserved data for a particular query, and you can send it as a response. It won't harm, correct? So always remember, your caching mechanism should only be applied on the safe HTTP methods, which are only the read operations. HTTP caching headers should be honored. Okay, when the client is making a call or when the client is making a request, he can send multiple headers along with the request, where you can have cache control, you have last modified, TTL, age. The client can send it, okay, and it has to be honored. Let's say if the client says that I only want the data which is stored for, let's say, 24 hours. The data which was stored before 24 hours, I'm not interested in that. If the data is stored before 24 hours, is cached, I want the implementation to give me the answer. I don't want the data to be from the cached memory. So these kind of headers should be honored. There are various headers, caching headers that we are not going to cover right now over here, but I can share the documentation. Please go through that particular data documentation to know more about caching. Okay. Now, we know a lot of advantages of caching, but there is one disadvantage. What is it? Caching does increase the memory footprint, right? When you want to store the data, you need somewhere to store your data, right? You need some place to actually preserve your data. So for that, definitely the memory footprint will increase. And how can we manage it in the Mule applications? Using the cache scope or your object store connector. It can be both, shared across workers, and it can be private to a particular worker as well. Okay. Last but not the least, your static results. If nothing works, okay, if you are done with all the fault tolerant mechanism and nothing is working right now, you actually need some time to recover or to take care of your system. Go ahead with static results. Prepared results may be used instead of the result expected from an API invocation. So basically, in a very layman language, I can say you have hard coded the answers. Okay, you have written it somewhere in the file, and when the user is trying to invoke the implementation, you are and your API implementation is not responding, just share the hard coded data. But definitely, it won't work for all the instances, right? It won't be able to work for all kind of data, but at least you can use it for some predefined data which is kind of fixed. For example, country's name, state's name, product's name. If there is an e-commerce website, then the list of products, if a user is browsing through, you can share the list of products. Currencies, that one country has this particular currency and it's not going to change right now. So at least you can hard code these data, and you can share it with your client instead of giving them errors. Again, this is not an ideal approach, right? This is absolutely not an ideal approach. But of course, instead of, again, we are talking from the network point of view, instead of keeping your clients waiting for a longer time, or giving them errors, where we talked about that fail fast and freeze, uh, don't freeze mechanism, it's okay if you have something that the client can use it for the time being, just share it. So that is the idea of your static results. Okay, so these were the strategies. Any questions, guys? These static results can be created using your property files in Mule applications. You can use your file system for that, and you can share it as a response when nothing is working. Correct? Any questions so far, guys? Okay. So when
So,
we talk about, huh?
we have one question from Rohit. Can we
Sorry.
have mix of strategies?
Absolutely, Rohit. I was just about to say that to conclude. So we are almost done with the strategy. So as I was saying, that when you are actually applying the fault tolerance mechanism on your application network, you can use all of them together in your APIs. Okay, of course, depending upon the criterias, depending upon the situations, you can have mix of strategies also. Like in the starting only, we talked about timeout and retry. Similarly, if retry is also not working, then what can you do? You can use a fallback API. Let's say you do not have a fallback API, you can use a client cache. If you do not have a client cache mechanism, also use the static results. So of course, you can use the combinations. Okay, you can use the combinations depending upon the costing, depending upon the availability of the systems, and you can apply this fault tolerance mechanism over your APIs. So of course, Rohit, yes, of course we can do that. Okay. All right, so I wanted to keep this session very small and theoretical, just to introduce you about the strategies of your fault tolerance. Probably in upcoming sessions, we can have some live demos also. Right now, I do not have that setup, so I won't be able to show it to you. But yeah, this is it from my end. If you do not have any questions.